hi there. How's everyone been doing so far throughout the event? Thank you for joining our session. I really appreciate I see that currently we have 39 attendees in our session, so thank you for coming. We're also the co-organizers this time round for Data Kita Pulse, so we're really glad to be hosting this event for you guys today. So before we start off in the guide for hiring data roles, I'm going to pull up some poll questions, and I would love if you could help participate. So good evening to you too. All right, so the first question I have is, do you currently collect data in your business? Please let me know. Wow, it seems like quite a number of you guys collect data in your business. Wow, that's amazing. Okay, wow, that's an overwhelming 85% that you guys collect data in your business. That's great. Okay, next question I have for you is, are you collecting data that is useful to help you with your business goals? Let me know what you say. Wow, over 92%. Oh, some of you say no. Interesting. Okay. All right. Thank you so much. Okay. Third question I have for everybody is the data that you're currently storing in one place and in a unified format? Let me know. No. Wow. I'm quite surprised by this. I thought all of you were collecting data at this moment. So they're not unified. Interesting. Thank you so much for your participation. All right, last question. I want to ask if you have a clear understanding of why you want to hire a data role. I'm assuming that today you've joined my session because you would like to know more about this. So do let me know if maybe some of you are looking to hire for data roles. Do you know why you want to hire data roles? Oh, it seems like it's a 50-50 at this moment. Okay, so 52% say yes, and 40% of you guys say no, which is really interesting because I would think that maybe all of you might say no. That's why you're here to join me today. Okay, thank you very much for your participation. All right. So today I'm going to be presenting about a guide that we use in hiring data roles. Usually this presentation is more so for people who have no understanding about the different data roles as well as the technologies out there, and that's what I am here today to help you with. Okay? Can everyone see my screen? If you can, do put a thumbs up in the chat so that I know that you can see my screen. Okay, I'm assuming that you can. All right, so a guide to hiring for data roles. Okay, thank you for your response, One Nor. So the first two things I would like to say is, before we talk about hiring, what are the two things that you think is necessary before hiring for data roles? What do you think? Let me know in the chat. What are the two things that are really crucial to know before hiring for data roles? Okay, I see that we don't have any response so far. So I'm going to tell you. Well, the first thing, as you can see from my questions that I asked earlier, 1 is business goals, and 2 is data, right? Of course, you need data before you hire data roles. Otherwise, why would you even hire? So what I mean by business goals, I mean by ironing out in your own company specific business goals that you would like to achieve. And I'm going to give you some examples. For example, if I was a supermarket chain, and basically the reason why I would want to hire a data role is to maybe find potential new areas with the highest concentration of customers and the lowest concentration of existing supermarkets, right? I think after you have identified the business problems and opportunities you want to address, Then comes your data. Now, the thing is, there is a misconception that sometimes people think, I need large amounts of data, then I can hire for data roles. That's not necessarily true. Sometimes you don't need large amounts of data, but definitely you need data that relates to the business goals that you have identified earlier on. Now, a spreadsheet with probably a few 100,000 rows with the right data attributes is enough. Okay, so I'm going to dabble into the different data roles there are currently on a high level. And I think the best way to explain this is by the data science production lifecycle. So over here you can see you have collection, cleaning, exploratory data analysis, model building, and model deployment. So to start anything before hiring for a data role, you need data. So data collection means to aggregate and store the data. Data cleaning means that the data needs to be usable and stored in a way that it's easily accessible. Exploratory data analysis, also known as EDA, is basically for you to be able to look for trends on a high level and insights into the current data that you have. Model building is about predicting the outcomes from your analysis. And lastly, model deployment is about taking our machine models that we have built and making them scalable for the business. So I'm going to talk about the data scientist role. As you can see over here, that it basically encompasses all the data science production lifecycle, right? But traditionally, data scientists basically covers like the whole spectrum of the life cycle, but sometimes people can specialize in some areas, depending on the size of the company. Usually, data scientists are only hired by companies that have large sets of data. A data scientist usually has the expertise in probably statistics and building machine learning models and making predictions to answer key business questions. Now, although data scientists typically can do whatever the data analyst and the engineer does, but the real difference is that they build predictive models and use advanced programming language to help with the decision-making process and business strategies for the future of the company. Usually a data scientist is definitely not an entry level. It's probably people who have really advanced degrees, or someone, if they don't have advanced degrees, with a lot of experience. This role usually is a high impact role, often dealing with a lot of C-level people. And to give you an example of what a data scientist does, I want you to imagine. So imagine on Google search, right? If you key in, I want to hire a data analyst. You probably see pretty relevant results, am I right? The data scientist basically builds the algorithm to help you sift through all the huge data available and present it in the most relevant result on Google, which helps you save a lot of time. Don't you agree? So instead of you endlessly searching for well-written articles, you have data scientists to help you make your life easier. Now, data scientists are usually, in charge of large groups of data sets. They find patterns and interpret it to allow businesses to make actionable decisions. Okay, so that's the data scientist role. The next role I would like to talk about is the data engineer. Now, as you can see on the slides that I have, that data engineer comprises of the collection and the cleaning process. Now, data engineers care about how to collect data and how to store the data and how to make the data accessible to all the different people to be able to query from. Usually, they're in charge of organizing like storage systems, warehousing, and transforming data into more usable formats for people like us to understand. Well, the skill sets that usually a data engineer has is they have knowledge of like distributed systems. They have knowledge about architecting data warehouses and storage points. And they have the ability to pull data and transform it into many useful formats for the data analyst to work on. Technologies that a data engineer is often involved in includes R, Python, or like big data frameworks like Hadoop or Spark, or even cloud computing technologies like AWS. Basically, data engineers deal with large amounts of data, and they control the data and scale it for production so that many people can have access to it in a distributed and efficient way. They basically empower people to query from databases efficiently and effectively. And usually these people come from software engineering backgrounds in computer science or have a strong understanding of data structures and distributed systems and how to engineer them. So I'm going to move on to the data analyst role. As you can see, the data analyst usually is involved in cleaning and exploratory data analysis, also known as EDA. Now, the difference between a data engineer and a data analyst is that the engineer is building the pipeline that will allow for data analysts or data scientists to query the data, meaning to extract the data. Now, data analysts are in charge of mining the data sets that have already been availably made by the data engineer to them. And then in terms of EDA, what they're interested in looking at is curating patterns and insights and being able to deliver like business intelligence reports for the business. So usually the tools that they use are more on BI tools, and BI stands for business intelligence tools. For example, Excel, Tableau, or Power BI. Tools that help them basically visualize data in terms of what is going on. They also work on descriptive analysis, so they figure out why certain things have happened. So for example, if I'm a supermarket and suddenly on November the 20th, my sales increased by 90%. Why? Basically, the data analyst is in charge of finding out why. So it could be due, maybe it's near to Christmas and they change the packaging to red. So that's what they are in charge of, drawing insights and reporting what they can see in the data. Okay. So for machine learning engineers, as you can all see over here, you see model building and model deployment. Am I right? Now for machine learning engineers, they're basically in charge of building models and putting the models into production, meaning into large scale. And they usually work with a lot of software engineer stakeholders in the company to make sure that the models that they build work with the infrastructure that the company currently has. Technologies that usually a machine learning engineer would use is probably Python, and usually they would have a strong knowledge in Python, or other languages in the companies, like probably Java or Scala. So usually a machine learning engineer has a very strong technical understanding of machine learning tools and production environments. So the difference between a data scientist and a data engineer, I usually like to use the analogy of a car. So imagine the data scientist is basically the person that builds the model of the car, deciding what engine, what structure, what color shall it be, etc. like that. As for the data engineer, they would take that car model and scale it for production efficiently for it to be able to reproduce in their company. So that's how I like to differentiate the two. So here is a brief diagram, maybe to allow you to better understand how they correlate and how the different roles, expertise are in. So moving on, is this you? There's so many technologies out there, and I don't understand any of the technical terms. And probably if you're looking in your company to hire for a data role, maybe you'll be thinking, where do I even start? What should I use? What technology should I use for my company? So I'm going to walk you through the 8 common data science technologies out there. And I've categorized them into 8 different categories: programming language, database, cloud, BI tools, applications, deep learning frameworks, and library. Okay, so first with programming language. Do you know what a programming language is? Well, at first I didn't know. And the way I like to put it is that it's a language that you use to talk to the computer. Now, there are many different languages built out there for different purposes. They perform in different ways, and some of them are specific to different systems. Like, for example, on iOS, you have another language. On Android, you have another language that you use to communicate with your computer. Now, in data science, one of the most popular programming languages is actually Python. Python, they call it a production-ready language, meaning that it has a capacity that in one single tool, it is able to integrate with every part of your workflow. So whether if you want to build like a web application or machine learning model, Python can get you there. It's a language that basically you can use for all purposes, I would say, and it widely is considered as an accessible programming language, meaning that it's very easy to read and learn. The language is also often used in very cutting-edge machine learning models and AI applications, and it's commonly used to putting models in production. So those who don't know in production, remember how I said scale? That's what it means. It also has a very high ease of deployment and reproducibility. Okay, so that's more about Python. If you want to know more about Python, you can read it up on Google. Now, the second language I want to introduce is SQL. So SQL is called structured query language. And basically, it's a language where you use to query data. So obviously, all the data that we have, most of the raw data, it lives in collections of tables called relational databases. And data analysts and data scientists use SQL, to extract data from these databases. So usually it's very useful for every organization, and it's often used in every organization that usually stores information in databases, and it's one of the most in-demand skills for businesses. Usually at SQL, you're able to query data, manipulate data, and access the data and control the data. Okay, so for databases are basically structured to facilitate the storage of your data, to help with retrieval, modification, deletion of data with any other data processing operations. So this is how I like to put it. Imagine structures are like rooms where you're able to store data. And in each room, there are many racks. And each rack, there is a table with data in it. So that's basically what databases are. So I want to talk about the common databases out there for data science. Usually there's like Microsoft SQL Server. So usually this is used for commercial use. There's also Postgres, which is an open source relational database management. And there's also Oracle database, which is often used by 97% of the Fortune 500 companies. Next off is the cloud platforms. So for cloud platforms, I think all of you have seen that, there's AWS, that's everywhere, and there's also Azure, right? So traditionally speaking, what cloud is that usually in the olden days, you would spend much money on very expensive computers and servers to host your applications to run. But now instead of buying these expensive computers and servers, you basically use the cloud that is provided by one of these top cloud to help you run your applications. Next up, we have business intelligence tools. I think many of you may have heard Tableau and Power BI. So in terms of business intelligence tools, they're not very advanced. It's quite okay for beginners like us. They help basically collect data in one place and gain insight into what moves the needle, what's the forecast outcomes, and many more other things. So the common one, Tableau, is used for data visualization. Basically, imagine it as a supercharged Microsoft Excel. Simple for anyone to, access, analyze, and create highly impactful data visualizations. It also supports multiple data sources. That's why it's one of the most, most hot tools out there, including like Microsoft Excel, Oracle, Microsoft SQL, and Google Analytics, and many other things. The next tool that is very common as well is Power BI, which is by Microsoft, which allows users to basically transform raw data, add calculated columns and measures to create simple visualizations that will combine them to create interactive reports. Okay, so that's basically for business intelligence tools. In terms of applications, there are many applications out there to help you with your programming. And these two applications are quite common. First is Git. So what Git helps you is with the version control of power tools of programming. So basically it allows you to keep track of what you did, undo any changes if you decided that you don't like it, and collaborate with other people at scale. It's a very common tool that not only data scientists use, but a lot of software developers use as well. The next up, we also have Docker. I really love their logo. Every time I think about the C when I see Docker. So Docker is, imagine it as a sandbox, basically. It's an environment to drastically reduce the risk of software in production stage. So for example, maybe your software that you build, you want to push it out, but you want to test to make sure that everything is working well before you push it out, right? So Docker is an environment where you are able to put in your code and see if it is compatible with your current code. Next off is deep learning frameworks. So in deep learning frameworks, there's the very famous ones are TensorFlow, Keras, and PyTorch. TensorFlow is, I would say, one of the most popular frameworks out there in deep learning. But I would say PyTorch is also upcoming and growing really fast. And then we have big data frameworks. For example, Hadoop, which is an open source program that allows anyone to use like the backbone of their data operations. And then there's also Spark, which is a framework that provides a number of interconnected platforms, systems, and standards for big data projects. They're very, very commonly used. And lastly, there is the library. So in terms of library and data science, a very, very famous library is called Pandas. And Pandas is basically used for data manipulation. Pandas is is very popular with Python. And it offers like very powerful, expressive, and flexible data structures to help make data manipulation and analysis really easy among any other thing. There's also scikit-learn, which is usually used for machine learning. It's free. It's a free library for Python, and it features various algorithms providing a range of supervised and unsupervised learning algorithms via a consistent interface in Python. So I know what I've been mentioning to you for those who are new to tech may be like too much information. So I'm going to break it down to you in terms of the difference between what a framework and library is. I often like to use the house as a metaphor for web development concepts. So a library is like going to IKEA. You already have a home, but you need a bit of help with furniture, right? You don't feel like making a table from scratch on your own. And IKEA allows you to choose different things to go into your home, right? So thinking of like beds or like sinks and stuff like that, that's basically what a library is. Imagine it as a plugin. Whereas a framework, on the other hand, is like building these model homes. So maybe you have a set of blueprints of how to design a house, how to architect a house. And basically, that's what the framework is. I give you a framework of how to build certain things. There's already a certain design and certain architect to it. You can just copy and paste it and use it for your own use. So that's basically the 8 categories of the common technologies in data science. I hope I did not give you too much information. Now, I want to talk about the common technologies in job listings in 2019 for data science. Over here, you can see that Python, R, and SQL, and Spark and Hadoop are the most common ones, right? It is one of the most common ones. But then I also want you to see the change in average of technologies, average percentage of change in data science job listings in 2019 as well. You can see that the leading ones that are, people keep adding technologies. The common technologies that people keep using are probably like AWS, PyTorch, and Azure. And they are increasing really fast. Whereas earlier, remember we mentioned that R was one of the most common technologies. It's basically, as you can see, the last on the row of the graph, where a lot of companies are actually moving away from R. So think about, if you're thinking of technologies to adapt to your company, think about these things. So that's about it from my part. I'm going to pass the floor to my colleague. And later on, I see that there have been questions in the chat. We will answer them later. So she'll be explaining on the know-how of how to hire data professionals.
Hi everyone, my name is Ruvina Danaraj and I'm from the Folkwell team. So we specialize specifically in HR technologies. So I'd like to share some interesting insights when it comes to hiring data professionals. This can be whether it's to pre-screening candidates to resumes or experiencing the interview stage with your candidates. So as you can see here on my slide, we have 5 traits. We have the analytical mindset, we have proactive, we have technologies, projects, and a learner. So let me dive deep into each topic. So this slide is about analytical mindset. The most important criteria of a candidate is that they have to have an analytical mindset for any data role. The top 3 topics that are constantly coming up is calculus, linear algebra, and statistics. Now, a candidate should always be asking questions about why things are happening a certain way or how they are happening. They should get down to the root of the problem. So this is important that a candidate should know that curiosity is key. And it's a common misconception that one should come from a data science background. But in some other cases, you can find a strong candidate if, say, they come from a risk management in a banking industry, or they have a strong accounting or financial background. As long as they know how to crunch down on numbers and deal with Excel, they have unlocked potential. So the next is proactiveness. Sorry, I think I missed this slide. 1 second. So proactiveness. Has the candidate taken any online courses, whether it's on Coursera or have they had any certifications? Proactiveness, I mean, when you have online courses like this, it adds a boost to the resume. You can see whether they've had taken courses like visualizing data with Python and so on. This allows them to differentiate from the crowd of candidates. Okay, So moving on to technologies. Emerging technologies have been changing the entire landscape of storing and analyzing data. A good candidate should be well aware of at least one programming language, as Poisson mentioned. For instance, Python and R, which can be used for machine learning, and SQL is a must, which is the structured query language, which is used to pull out findings to a database. Another way to test a candidate is to ask them to choose a language they like, say Python, and ask them to demonstrate a key pattern in a small data set, and ask them to create and explain a data visualization. So I like this part, projects. Now the question is, have they gone on the internet and have they downloaded a fresh set of data? I'm talking about real life data. Have they done a proper analysis of the data or anything? Now, a good indicator of a candidate is that they participated in hackathons or other forms of competition. Most likely, during these hackathons, participants are asked to dabble into real-life data sets to achieve a relevant solution to the theme or problem statement of the hackathon. And lastly, the candidate should actually have this love of learning. They must love to learn and have the mindset of never giving up, because you may not always find the solution within a night. It takes a lot of burning midnight oil to find that one solution to your problem. So data professionals are always learning or relearning skills on the job. Some good signs of a candidate is that they are familiar with platforms like Stack Overflow. If you haven't heard of Stack Overflow, it is one of the largest communities for programmers to learn. Now, some common misconceptions. Candidates, they don't necessarily have to have a PhD in math or some other research area. Data scientists are multidisciplinary, not just experts in one field only. Strong data scientists are often motivated, who constantly learn through experience and investigation, not necessarily requiring a degree to have the necessary skills. Another misconception is that they must be a Hadoop expert. As Poisson mentioned, Hadoop is a database framework, so a data scientist definitely needs technical skills, but many hirers confuse this with being an infrastructure engineer. A data scientist must be comfortable interacting with systems like Hadoop, but it shouldn't be a filter when trying to find leads. However, data scientists should be proficient with SQL, Python, and R. Then lastly, you should be aware of the imposter data scientists. Many people label themselves as data scientists, but may have the necessary experience. They may have run a regression in Excel or at some point, but don't have the extended technical and quantitative depth. When interviewing, you should question them on the statistics knowledge. Can they write code? So I have some very simple examples of a resume. So as you can see the green tick, this is a good resume, only because I took part of the resume, which is the one I liked, which is a project description. So if you can see, it's a bit small on the screen. You can see this candidate has written the projects. So the first project is the lag factor, and the description says predict delay in reporting of shop visits. And the impact and tech stack used help estimate sales prior to sale being reported using Python, Postgres, Spotfire, linear regression, and pandas. So this is what kind of highlights, from a lot of resumes. Now I'm going to show you a bad resume. So many, not considered bad, but it needs a bit more work. So this candidate basically explained the work experience, but it's missing that description. It's missing that role and responsibilities in his resume. As you can see, he's just worked on live projects on a daily basis, but it needs a bit more explanation than that. Developed many predictive models, which could actually have some examples, and processing, cleansing, verifying the integrity of data and for analysis. So in this case, I think the candidate needs to just describe a bit more about the tech stack that he had used, what was the outcome of that, and so on. Okay, so now going on to technical assessments. Technical assessments can be hard, especially when you don't have a technical background. Luckily, we have these useful platforms to help you assess a candidate on their said skills. So we have HackerRank, Triple Byte, and LeetCode. Feel free to take a picture of this slide so you can have a look at it. So these platforms cover topics like basic programming, algorithms, and systems design. These platforms have judges or at least some sort of scoring system. Usually, if you do have an internal tech person in your company, they can review the code, or the scores might be sufficient for you to identify a good candidate. So moving on to salary expectations. First, if you're talking about fresh graduates, that those don't have work experience and so on, the usual market rate is between 3,000 to 3,500 Malaysian ringgit. But if you're talking about a data analysis, data engineer and scientist, you're starting junior level 0 to 3 years, 4 to 6,000 ringgit, mid level 3 to 6 years, 7 to 10,000 ringgit, and 7 to 12,000 ringgit for a data engineer and data scientist. Now, if you're talking about a senior level, 7 to 10 years, a data analyst can have 11,000 to 17,000 ringgit per month, and a data engineer and scientist is 13,000 to 20,000 ringgit. Okay. So here's the fun part. I think we have not really explained about Folkwell. So who are we? So Folkwell.io, we are a platform for software developers and data scientists to find job happiness all over the planet. So we actually get empowered by getting a software engineer or a data scientist to find the right job in the right company. So that is our mission. And this is a bit of our history. We've hosted over 500 events with 40,000 attendees across 30 countries. And some of our partners include Microsoft, Sony, AWS, NASA, DigitalOcean, Line, Rakuten, and Sunway iLabs. So as you can see, the pictures are a bit small, but this is our community. We have co-hosted or hosted AI and Big Data Challenge Thailand, Women Who Code Malaysia, Honeybee Hack Russia, Groove's Global Meetup Japan, the NASA Hackathon Malaysia, the Singularity Japan, and Work Rules Japan. So that's a bit of our background. And we understand that now is very hard times during this pandemic. So we'd like to help any type of company, SMEs, startups, and you can actually post on our platform for free because, we want to give opportunities to our community to allow them to find the right job and career. Okay. So now we'll leave it to the Q&A. Horsan will join me.
Hi guys. I see that there are quite a number of questions, and I see that Johan, thank you so much for helping answer a few. So I was actually wondering if it would be possible if I can invite Johan on stage with us to maybe share about what Mohani has mentioned. She said for non-tech persons, what does data mining for data analysts do? Do you think you can grab a mic? Okay, he's a little shy, I guess not. So to answer, Mohani, your question in what data mining is for data analysts, is basically they look through the data and they are able to identify and try and figure out and mine insights into what the data has, basically. Does that answer your question? Basically, they're trying to mine out insights and opportunities for businesses. So that's what the data analyst does. Yeah? Okay. Now, the next question that we have is how about the R language? What's its practical use in the industry? I think for the R language, there's many different applications that you can use it for. Well, one useful way is probably to go on GitHub and you'll be able to see, people using R, building different types of projects, and you get an idea of the possibilities of what R can bring to the industry.
Or you can visit Stack Overflow, which is a great community. You can always post any questions related to R. and then you can see the whole community respond to any of your questions related to that.
Yeah. Okay. Let's see. Are there any more questions? How much potential of big data and AI in order to improve human resource management? For example, during staff recruitment and selection, how can we use machine learning for job matching?
Now, yeah, we've had this question quite often. How can it help? I mean, ideally, it takes a lot of time for, say, like a recruiter to shuffle through like at least 100 resumes when you can get a machine to do that, or you get previous data from resumes. I mean, resumes, they have a lot of certain key traits that you can pick up, technologies or work experience or even projects, and that can be actually be input into a database. Where machine learning, it can actually help us predict that we want maybe the top Flutter developer or like data science, and then they can come up with recommendations for us, right?
Yeah. To add on to that you can actually teach a machine learning model. I think recently there's a really cool analogy. Basically, imagine this. If Ruvina is a beautiful lady, and let's just say there is a guy out there that, really wants to get to know Ruvina. And so what basically he would do is that he'd probably give her a rock, and then she'll be like, I don't like it. And then next thing is she gives her flowers, and then she's like, oh, I actually like that. And then it gives her probably a snake, and then you're like, oh no, I don't like that. So basically a machine learning model is basically able to, with your input of teaching it, telling them what is a good resume, what is a bad resume, in terms of recruitment, eventually you'll be able to build up a model that will help you basically shuffle through your resumes or your applications through that. So I think that's another way of application.
It saves time and it's more efficient and accurate compared to the human manpower that you need when you're looking at each resume.
But I have to say one thing is that the human element in recruitment sometimes is
not replaceable.
Exactly. Yeah. It's not replaceable. It can only help you with like the pre-stages, but I don't think it can help you like all the way to get someone hired. Maybe in the future, but right now I haven't seen that available. Okay. All right. Next question. This will be our last question as time is up. In terms of salary range, are there any differences between expats and locals for mid-level data scientists?
To my knowledge, I'd say there's no huge difference, honestly. It really depends on the experience of that candidate and the knowledge. I don't think there's some form of differentiation. It really, honestly, some employers, if they're looking for, junior level, mid-level, or even senior level, they like to actually just interview the candidate themselves and see where they fit well, and then only propose the salary, actually, what they're expecting. So it's more on the individual's skills and knowledge and work experience, in my opinion. I haven't seen a huge difference between expats or locals. I think it's pretty much the same, but based on their skills and potential.
Agreed. I totally agree with Ruvina. I have the same experience, and we're on par.
Yeah.
Cool. So, unfortunately, time is up. I understand that there are other questions on the floor. Maybe you can connect with us offline, or actually, we're going to be hosting our humanized virtual networking session right after this, and maybe you'll be able to meet people who are more experts than us that will be able to answer your questions. So please don't miss out on that, okay? So before we end, would you do the honor?
We'd like to take a group fee. So it will indicate to all the audience to take a selfie, and then it will be compiled to a nice image. So please take a group fee. Please.
Okay. One moment. Let's start the group fee. Okay. please do submit a group fee. We would love to have your faces. And it also gives us an understanding of, who has been actually listening to our
Who enjoyed our session.
Oh, only 3. That's sad.
No.
Oh.
More.
Yay.
Thanks. Our smiles will be bigger.
Okay. We'll wait another minute for others to submit your selfie. This selfie you can save and probably tag us on LinkedIn. And definitely do connect with Ruvina and I on LinkedIn. We're always open to having a conversation. So thank you. Thank you guys for joining. Bye. Wait, let me end the group fee first. Okay. Thank you. I see big smiles on there. All right. Thank you very much. Do check out our next session is going to be the virtual humanized working session. It's really, really fun, really a good way to get connected with other people. So don't miss out on that session.
You have to experience it. It's really cool.
Okay. Bye, guys.